8 times 8 equals 54? That's completely wrong. That's exactly what I thought when I first saw this puzzle. But here's the thing, this isn't a mistake. It's actually a brilliant riddle that will make you question everything you think you know about numbers. Here's the challenge. If we live in a world where 8 times 8 is 54, then what does the number 84 equal? I know it sounds absolutely insane, but this puzzle is 100% solvable using real mathematics. No tricks, no wordplay, just pure logical reasoning that will blow your mind once you see the solution. Before you click away thinking this is impossible, a secret lies in understanding that there's a hidden mathematical system at work here. Fair warning, once you see the answer, you'll never look at this puzzle the same way again. And you'll probably spend the rest of the day creating your own versions to stump your friends. Ready to have your mind blown? Let's dive in. 3, 2, 1. You've probably understood that the numbers in this problem world are not in the decimal system of notation, but in some other number system, as the question, what is the number 84, only makes sense if we're operating in a completely different number base altogether. The standard number system that we use every day is base 10, where each digit's position represents a power of 10. Let's use the number 24 to illustrate this. We can split 24 into its separate digits, 2 and 4. 4, the rightmost digit, is in the units column, representing 4 ones. 2 is in the tens column, so it represents 2 lots of tens. Each column goes up in increasing powers of the base. So as we're in base 10, we would have 10 to the power of 0, which is 1 for the units column, 10 to the power of 1 for the tens column, and 10 to the power of 2 for the hundreds column. This means if we were to represent the number 124, we would have a 1 in the hundreds column, representing 1 lots of 10 to the power of 2, 1 lots of 100. Another useful way of looking at the base system is to use algebra. We can represent one unit of our base using x. This means we can represent 24 as 2x plus 4, where x is equal to 10. We can see when we pop 10 into x, we get 2 times 10 plus 4, which is 20 plus 4, 24. This is the key to solving our puzzle. We can represent the number we want in this format to determine the base system our puzzle is using, which is the x in our question. Back to our challenge. If 8 times 8 is 54, what is the number 84? Let's simplify the left-hand side. 8 times 8, which is 64. This means 64 corresponds to 54 in our problem world. To figure out what base is being used, let's split 54 in the same way we would split 24 to represent its base. Split it into its separate digits and stick an x next to the 5 to represent one unit of the base. We now have an equation in terms of the base x, which we can solve. Subtract 4 from both sides to get 60. 60 is equal to 5x. Divide both sides to get x is equal to 12. The base system the question uses is 12. With this information, we can form our attack plan. What is the number 84? What normal number in base 10 is represented by 84 in base 12? We can split 84 into its separate digits, 8x plus 4, and stick an 12 into the x, as this is our base that we figured out. 8 times 12 is 96, and 96 plus 4 is 100, giving 100 as the final answer. The number 84 in our question is equal to 100. This problem opens up an entire avenue of further puzzles to do with swapping different number bases. Why not create your own and put them in the comment section for other people to have fun solving? By far the most useful number base beyond our standard base 10 would be base 2, also known as binary, which only uses 2 digits, 0 and 1, to represent the on-off electrical states in computers. Fantastic! Thanks for watching Beat the Calculator. See you next time for more logic and maths fun.